electromagnetic wave, or simply call it EM wave, EM wave. So we'll talk about the energy transport, Poynting vector, or radiation pressure, polarization. Actually, the video just now is about the polarization and reflection and refraction. Total internal reflection, polarization by reflection. Actually, you should have learned it in high school, maybe. So before we talk about the physics, we talk about the Bible. Yeah, so 创世纪的第一章1到3节这个是NIV New International Version， 就是我也不知道，反正有很多版本。那就是起初神創造天地嘛，地是空虛混沌啊，淵面黑暗，神的靈運行在水面上啊。神說要有光，就有了光。那我没有办法用普通话念，因为从小到大都是用粤语学的，所以我也你要我用普通话背出来的话，我也没办法。但是so actually in the Bible is something like God said, "Let there be light," and there was light. So actually, the God spent 6 days to create the world and spend an additional day to take a rest. So in physics, actually this is called the Maxwell Rainbow. So so this axis is the frequency, and this one is wavelength. So they are inverse proportional to each other. 它们是互为反比的，就是频率越大，就是波长就越短，波长越短。So actually, this is called a radio wave. Somehow like 10 to 6 hertz, 10 to 6, which is megahertz, 10 megahertz, 100 megahertz, gigahertz. So we use this for transmit RF signals, something like FM radio, Wi-Fi, 2G, 3G, 4G, 5G, so on. Near this range, maybe 5G, we use the millimeter wave, something like here, use the 30 gigahertz, around 30 gigahertz, maybe 29 point something. So here is the infrared and the ultraviolet, 红外线跟紫外线. And this is the visible light. This is the visible light. So we have red, orange, yellow, green, blue, and violet. So this is the visible light. This is the visible light. And yeah, this is about hundreds of nanometer. The wavelength of the visible light is about from 400 to 700 nanometer as the wavelength. And longer than this is called the infrared. 红外线就短的叫紫外线ultraviolet. And here is the X-ray, and then the gamma ray, So for the right side, it is more higher power. It is much higher power. So in chapter 38, you learn that E equals HF. So this is the frequency of the light, of the photon, and this is the Planck constant. 6.63 times 10 to minus 34. So within this range, we have AM radio, FM radio, maybe for the Macau 100.7 megahertz or whatever. And this is a TV channel using the maybe the VHF and UHF lies between maybe tens of megahertz to several hundreds of megahertz. And then here is the part maybe for Wi-Fi we use the 2.4 gigahertz and 5 gigahertz, 5 gigahertz for the Wi-Fi, and for their whatever G, they may use hundreds of megahertz or several gigahertz to transmit signal. So in Maxwell's time, around 200 years ago, actually mid 19th century, the visible infrared violet form of light were only electromagnetic wave known. 所以当时他们只知道可见光、红外线跟紫外线，其他的他们并不知道。Okay. Actually, spurs on the Maxwell work, however, Heinrich Hertz discovered what we now call the radio wave. So actually, this guy discovered the radio wave. So the SI unit for the frequency is named after him. It's named after him, Hertz. So and verify that they move through the laboratory at the same speed as visible light. Indicate that they have the same basic nature as visible light. And now we know that a wide spectrum of electromagnetic wave, Maxwell Rainbow. 所以一个简单的一句话就是光是电磁波啊，光是电磁波。对。那时候还有一个故事，就是说当时啊，他们觉得光的传导需要介质，They should need some matter for the light to transmit, something like the voice, maybe the voice. We know that without the air or without some sort of matter, the voice cannot be transmitted. Maybe we can use a cup with a line to transmit some voice, but actually without anything, the voice cannot be transmitted. And at that time, they imagined there was something called the ether to transmit the light. And they make this assumption to fulfill the Newtonian physics 啊，当时他们为了满足那个牛顿力学，他们幻想了一个叫做以太的一种物质啊，一种介质来传导那个电磁波的传导光的。但事实上最后是证明是错误的。当时19世纪就是这个 mid 18th， 就是大概50年后嘛，大概他们就是很希望有一种叫做以太的东西，就是他们希望这个世界有一种叫做绝对空间的概念。然后那个物质可以传导那个光的，但事实上这个并不存在哦。我们最后就是发现电磁波可以在真空中传播，它不需要任何的介质。那也因为这样，后来才会有那个狭义相对论或者是其他的理论的出现。So this is just a short story about the electromagnetic wave. So here we talk about how the EM wave travels. So suppose we have an energy source here, and then we have the RLC circuit as an oscillator, and then with a transformer. So actually, this should oscillate close to 1 over square root of LC something like this, maybe a little bit lower because we have an R here. And then through this transformer, this power will transfer to the secondary loop. An arrangement for generating a traveling EM wave in the short wave radio region of the spectrum, an LC oscillator produces a sinusoidal current in the antenna, which generate the wave. So in the secondary term, it will generate the EM wave. So this is like an antenna, 就是像根天线的哦。那 so this is a electric dipole antenna. So this side is positive, this is negative, and this will generate some EM wave here. So P is a distant point at which a detector can monitor the wave travel past it. So suppose there is a sensor placing here, so it can sense the EM wave generate, whether there are some EM waves generated by this setting. So in this case, we can see that the E field and the B field change with time at one wavelength of the wave sweep past the distant point P. So the wave is traveling direct out of the page. We choose a distant point so that the curvature of the wave is small enough to detect. At such point, the wave is said to be a plane wave, and discussion of the wave is much simpler. 所以它这里是说，它把这个点放在很远的地方啊，本来它像是一个球形的传播，那如果在很远很远的地方，那个球形呢就看起来很像一个平面，所以在讨论平面波啊，when we discuss the plane wave, it will be much simplified. So several key features they are present regardless of how the wave is created. The E and B field are always perpendicular to the direction in which the wave is traveling. So you can imagine the wave is traveling in this axis. So this may be known as the pointing vector. Known as the pointing vector. I will discuss it a bit later. And actually, the E field and B field will perpendicular to this pointing vector. And also, E field and B field is always perpendicular to the magnetic field. So it's somehow like we have E field is perpendicular to the B field, and E field perpendicular to B field, E field perpendicular to the pointing vector, B field perpendicular to the pointing vector. Somehow like that. And actually, E cross B should be the same direction as the pointing vector, which is the direction of the wave propagation. So the cross product, E cross B, always gives the direction in which the wave travels. The field always vary sinusoidally. 就是正弦波的正弦波。Moreover, the field varies with the same frequency and in phase with each other. 它们是同相位的。So in keeping these features, we can deduce that electromagnetic wave travel along an x-axis and has an electric field E and B field that depends on x and t. So actually, in this Today we will talk about all the equation without too much mathematical derivation. Actually, for the after finish this slides, I will also have the supplementary for this chapter. And actually, we can use the differential form of the Maxwell equation to derive the wave equation. And then by solving the wave equation, we can have all these solution present today. So actually now you can just accept this equation to be like this according to some sort of observation. So in this case, we have E to be like this. So X is the propagation direction of the wave. So this is called X, and they are sinusoidal. So we use sine, although you can use cosine, but actually this doesn't make much difference. Actually, sine and cosine just have a 90-degree phase shift, so it doesn't really matter. And then K is called the wave number. K is called the wave number, which is 2 pi over lambda. So this is very important. This is very important relationship. Actually, we'll use it in chapter 33 and chapter 38. And lambda is, of course, the wavelength. So the SI unit for the lambda is meter. So the SI unit for the SI unit for the K is meter inverse. And the omega is the angular frequency of the EM wave. So actually omega is 2 pi f. So f is the frequency. So f should have a SI unit to be hertz, and omega should have SI unit to be radian per second. So we generally talk about the K axis, of course the x-axis, the displacement, and then omega t, and then yeah. So we better explain all the variable in here. So yeah. So you can see that the E field and B field are perpendicular to each other, and the P is assumed that the wave is propagating out of the page. You can use the right hand rule E cross B, so out of the page, which is the pointing vector direction. So they will vary in phase. So as long as E is maximized, B is maximized. E becomes smaller, B becomes smaller. All of them become zero. And then E should be in the maybe this size. Becomes smaller and then becomes zero. And then E goes to the other side, B also go to the other side. E become maximized in another direction, B become the maximum in another direction, and then going backward. So it will just looping forever, as long as there are no noise. So in this case, we can see that E should be EM times the sinusoidal, B times the same sinusoidal, but different BM, and both of them have the same phase. And now, the wave speed, the speed of the light, here is about is something like omega over k is the speed of the wave. its speed in vacuum is given in the symbol c rather than v, and that has the value given by c to be 1 over square root of mu naught epsilon naught, which is about 3 times 10 to 8 meter per second, or in chapter 38, sometimes we will use, or chapter 37, in the relativity, we sometimes will use 2.998 times 10 to the 8th, 10 to the 8th power to represent the speed of light. This will be a more precise, or if you need to know more about the foreign digit to actually you can check it on Wikipedia. You should have you could be able to find this number very easily. But yeah. Hopefully I remember it correctly. And actually, the speed of light is given by this expression 1 over the mu naught epsilon naught take the square. And regarding to this one, you can imagine for this one, for this argument, suppose it's maybe at time equals to 0, time equal to 0. And we may let x to be 0 also. So this argument is 0. And we can imagine, suppose for t equals to 1, t equals to 1, then we suppose this one also equals to 0, which means that x should be omega over k to make this argument to be 0. So we have omega over k here, which means that suppose we omega k kx minus omega t, maybe to be a constant phi, or maybe I can just take it to be 0. So for t equals to 0, suppose x should be 0, which means that maybe somehow like that. So suppose for t equals to 1 second, and I may still want this one to be 0. So actually x would be omega over k, which means that suppose for 1 second, the EM wave will go for many cycles, and this is the distance. So this is the speed of the light. And actually, here we have EM, we have BM, and they should satisfy this relationship, EM over BM to be C. In the supplementary note, I will tell you why they should satisfy this relationship. But actually, you can just keep it in mind first. So far. So next we talk about the energy transport and the Poynting vector. So the Poynting vector, the rate per unit area at which the energy is transported, real, and the electromagnetic wave is given by the Poynting vector. So a Poynting vector is of course a vector. So the direction is easier to understand. It's just the propagational direction of the EM wave, and the magnitude of it is the energy per unit area it transmits. Is the magnitude of the Poynting vector. So it is given by E cross B over mu naught. E cross B over mu naught. So the direction of the Poynting vector S of an EM wave at any point give the wave direction of travel and the direction of the energy transport at the point. So you can imagine there's a point source of electromagnetic wave emit the wave isotropically， 所以它是同心圆的传播，它有一个点，它就向四面八方传播。And so actually, these black arrows are the Poynting vector, at those points. So that is equal intensity in all directions. The intensity of the wave at distance r from a point source of power Ps is power is Ps, and I is called the intensity. So I is the Ps over Ps is the power for a given surface. Suppose at time t equals to t0, it propagate to this circle, and the next moment it propagate to here. So the energy should be conserved. So for here, it divide by maybe a smaller r, and then maybe propagate until here. The surface area is larger, so the energy density is lower, become lower because as the light transmits farther and farther. So the time average rate per unit area at which energy is transported is S average, which is called the intensity. And the intensity can be calculated like this one. So it is E root mean square over C mu naught. Actually here, as long as we have EM over BM to be C, we have EM over BM to be C. And actually, E root mean square should be EM over square root of EM. E root mean square should be EM over square root of 2. So we have E and EB. So we have EM, BM there. And actually, we can have BM equals to EM over C. So this term will become EM square over C. So we have something like E root mean square over C. And then we also have a mu naught here. Of course, we consider the average. So we take the root mean square rather than EM. this may be the peak power. So here we talk about the average power. So we use root mean square of the E rather than the EM, which is the peak E value. Okay, so here we have a sample problem. So when you look at the North Star, 北极星吧，you intercept light from the sun at a distance 431 light year， 431光年emitting energy at the rates 2.2 times 10 to 3 times that our sun P sun neglecting any atmosphere absorption 忽略掉大气的吸收find the RMS value of the electric and magnetic field when the starlight reach you. 他说那个北极星的发射的能量啊，比太阳啊还要大2200倍还要大2200倍，但是它是从431光年那边发射过来的，就是很远了，就是光年是一个距离嘛，就是光速走1年的距离就是光年了。So here we have I equals to PS over 4 pi r squared equals to E RMS square mu naught C, and actually we have R equals to 431 light year times 3 times 10 to 8, which is the speed of light, and then we need to multiply it by 3060, so seconds per hour, and then we need to multiply it by 365.25, roughly 365 and a fourth days per year. So it should be around 4.08 times 10 to 18 meter. 18 meter from us. So actually we have a ERMS to be PS mu naught C over 4 pi r square. Actually we just put this one to be here, and then take the square root, so it should be something like 3.9 times 10 to 26 times 2.2 times 10 to third power, and then mu naught is 4 pi times 10 to minus 7, and then speed of light is 3 times 10 to 8 over 4 pi times 4.08 times 10 to 18 square, take the square root. So in this case it is 1.24 times 10 to minus 3 Vm, or N over C. Depends which one you like. Actually, they should be the same. So ERMS should be like this, and so it asks you to find the RMS value of the electric and magnetic field when the strict starlight reach you. So ERMS is like this. This is one of the answer, and the other one, BRMS, should be ERMS. ERMS over C, so which is 1.24 times 10 to minus third power over 3 times 10 to 8, so which is 4.1 times 10 to minus 12 Tesla. So that is the second answer. This is the second answer.